Saxon Algebra 1, Lesson 110. Grab some paper and pencil or a nice marker, something that you enjoy writing with, because this lesson is an art project. And it is called, I'm going to rename it because I don't like John's name, it's too long, Nonlinear Shifts. Okay, that sounds weird. Don't worry about it. Let me show you where we're starting. We're going to do a lot of drawing on this page. We're going to make a lot of graphs. There won't be a ton of numbers. It's mostly going to be pictures. The first thing that we're going to draw is something familiar. This is the magic of John's teaching method. It's the magic of all the teaching that I've ever done. And that is, we always start something new by talking about something old. We want to get familiar. We want to stand on firm, solid ground before we veer off into the unknown. So if you ever feel at the beginning of a lesson like, we've done this before. Yes, I know. That's because I want your brain to go, oh yeah, I get this. It's not a big deal. That's my whole intention. So if you feel it, I'm glad. Okay, we're going to draw 4 graphs across the top of the page. And then we're going to continue this pattern down. We're going to fill this page with pictures. Okay. A while back, we talked about nonlinear graphs. And we said this is the way a quadratic function looks. And we said this is the way a cubic function looks. Is it coming back all of a sudden? Oh no, this is g, sorry. G of x equals x cubed. Square root, like that. H of x equals the square root of x. And then absolute value. That is a really crooked absolute value. Pretend it's straight, okay? And this one, we skip the letters and they go, for some reason, John chooses to go to P of x equals the absolute value of x. Okay, this is what we started with. This is the basic sketch of each one of these functions, and notice the equations of these functions are super simple. It's just x squared, x cubed, square root, absolute value. Now what we're gonna do is we're gonna play around a little bit and change these equations and look and see how the pictures change. So first we're going to talk about vertical shifts. What's the difference between vertical? The opposite is horizontal. Which one's which? I always go through this, just like my right hand and my left hand. I always have to think it through. Horizontal goes with the horizon. So vertical is up and down. Okay, good. Now we know that. So what we're going to do is say, how can we tweak these equations to move the pictures up and down on the y-axis? Well, we're going to draw 4 more pictures. So I'm just going to go ahead and put my graphs in so I can draw them as we go. They're not exactly the same, but they're close. Okay, so let's say that, and we're going to switch to upper cases because these are slightly different equations. You can see how handy these letters are. What happens if we change this equation to be +1? Okay, well, all it does is it bumps the same graph up 1 unit. What about if we bump the cubic one up? Okay, we just take the same thing, and instead of crossing over at 0, it crosses over at 1. Same with this. The bottom of it is not at 0 anymore. We bumped it up to 1. I'll rewrite the equations in a minute. The square root, same picture. It just gets bumped up to 1. And absolute value the same way. We just bump it to 1 and do the exact same picture. So we can fix our equations by saying these new functions are all equal to the basic one plus 1. You'll see later that not everyone is this obvious. Okay, what if we want to shift them down? Still a vertical shift, But instead of going up one, what if we wanted to go down one? What would the equations look like then? What would the graphs look like then? Okay. That's the way the equation would look, and look. Same thing, we just take the very same shape, pretend it's the same shape, that doesn't look the same. And we just drop it down. It's a vertical shift down, this is a vertical shift up. So these are two different kinds of vertical shifts. This one, the g of x would be equal to x cubed minus 1. There's minus 1, and it would go like this. I didn't put arrows on all of these. Oh my gosh, the art details are unending. H, are you keeping up with me? You can pause me anytime. I'm sure you know that. You're familiar with the way this here video format presentation works. Okay, this one we come down here to minus 1 and we go same shape. I'm trying to make them the same shape. And then this is P of x equals absolute value of x minus 1. Okay, so here's the cool thing about vertical shifts. The picture, if you will, the shape moves in the same direction as the sign. Same direction as the sign. Okay, that's your hint that maybe something else is going to be different, and that's exactly right. All right, so vertical shifts up, vertical shifts down, add one, subtract one. Picture stays the same, it just moves up and down. All right, so here's an example of how John might test us on this. Sketch the graph of f of x, oh, I didn't write the number. Example it's 110, what? 110.1. F of x equals absolute value of x plus 3. Okay, so we can make our graph super simple. We can just draw the top half because it's absolute value, so we know it's going to be like that. It's plus 3, so I'm just going to go a little bit up, and I'm just going to write 3 there. I'm not even going to bother to write in 1 or 2, and then I just go like that. And I'm done, and that's the right answer. Yay. Okay. Now I'm going to flip, and I'm going to quickly recopy. Oh my gosh, look, I didn't even do that. I'm going to recopy that top row of what we call parent functions. But then instead of going into the vertical shifts, we're going to talk about horizontal shifts. What if you want to move the shifts this way, along this axis? All right, flipping, checking to make sure I didn't lose my frame. Beautiful. Rewriting parent functions. 1, 2. Told you it would be an art project, didn't I? Okay, this is the parabola. We're using lowercase letters to describe those. That's x squared. Here comes the cubic function. It's the g of x equals x cubed. This is the square root function. We're using h for that. And then this is the absolute value, and that's supposed to be straight. I'm really challenged in my straight lines today. And this one, John switched to P. Don't even ask me why. I don't know. Okay, there's our parent functions again. That's the same as on the last page. That's the same as on the previous lesson. Now let's talk about horizontal shifts. Okay, that's where we're moving it right to left. Okay, so draw 4 more of these suckers. And you know, really, while we're at it, let's just leave a little bit of space in between and then draw 4 more, because, you know, we're going to need them. I'll tell you that right now. So many pictures to draw today. All right, so here we're going to see what happens if we move to the right. Okay, so I'm going to move this 1 unit to the right, this guy. I'm trying to draw it exactly the same. And this time, f of x equals, look what happens. The change doesn't get tacked on the outside. Let me just write this up here, since we can't see our other page. Okay, so in our old functions, if we wanted to change it for a vertical shift, we'd take the old function and then we just add that number to the end. Here, we're taking the opposite of the number and we're putting it right next to the x value, okay? There's a logical reason for this algebraically, but I don't want to get into that yet. Just trust me that this one we're moving on the y-axis, and this one we're moving on the x-axis, and that has a lot to do with the algebra of where the change letter goes. But just notice this pattern. Okay, here's our cubic function. We want to move it to +1. So it's going to be like this. And we say that the g of x equals x minus 1 cubed. Okay, here's our square root function. We bumped him 1 unit to the right. So that's the h of x equals the square root of x minus 1. See how we're keeping that -1 right close to the x? And then here, our absolute value guy, we'll call that one boom, boom. Okay, I got that line straight. And this one is p of x equals the absolute value of x minus 1. Opposite sign, right? We're moving it in the plus direction, but we're subtracting 1. And change number smushed right up next to the x. Okay, and then let's go through and do a new function. These are to the right. And these are to the left. Right, just like before on the vertical shifts, we did up and down. I didn't write that. Let me go back and write that. Because that matters to me, you guys. This is the up, and this is the down. Add that to your sketches if you would be so kind, so that you're clear on that. Man, looking back already on these vertical shifts, they were so kind to us, weren't they? Up meant add 1, down meant -1. None of this crazy opposite sign business. Ay, ay, ay. Life was so simple back when we were kids, wasn't it? Okay, so horizontal shifts are kooky in 2 ways. The number has the opposite sign than what you would logically think, and you have to take that number in the sign and smush it right up with the x, wherever the x is. It doesn't just tack on the end of the expression. It goes right in next to the x. Okay, so if we want to go to the left, then we add 1. Still smushing it right up next to. Weird, right? Okay, so here's our same parabola. Oh, that was a bad one. Sorry. Here's our cubic thing. This is g to the x equals x plus 1 cubed. These are all at -1. Let me just write that in. Here's -1. Here's our square root, and that is h to the x equals, again, it goes right in next to the x, and then our absolute value, that's p of x equals the absolute value of x plus 1. Okay? Whew. So, We can generalize, just like we said for the vertical shifts, there's like an abstracted rule we can use. When we want to do the horizontal shifts, the general expression is that the shifted version equals the original one K is the number of units we're changing it, right? So here we take the change and we tuck it right up next to the X and we subtract. So it's the opposite sign from what you would think. Okay? So now what does a problem look like in this lesson, or this part of the lesson? 110.2. Sketch the graph of f of x equals square root of x minus 3. This is, one thing I like about this lesson is it's a really good illustration of why we might use this functional notation. It's really useful in this lesson because it gives names to all of these. So when we want the square root function, we know, okay, that's an h, right? That's the h style. And we know it's a horizontal shift because the change is smacked right up next to the x. It's not tacked down to the end. It's right in there next to the x. And we know that with horizontal changes, we go in the opposite direction. So this is going to be horizontal change to the plus 3, 1, 2, 3. I'll put the marks there just to make it look official. And then we draw that style. Boom. That's our answer. And it's right. Yay. All right. Oh my gosh. How are you doing? Take a breath. We have one more category to introduce, and then a fourth piece. I know we need an intermission in this lesson, which, I mean, again, you might not be familiar with this, but there is a control on your video player that looks like this. And that means you can pause me. I know, come to me for all your technology needs. But seriously, this is gonna go on a little bit longer, so take a deep breath, pause if you need to. Go, shake it off. If you were a little older, I'd tell you to go have a stiff drink of whiskey, but I don't think that's appropriate, do you? Plus, it wouldn't even help. I don't really drink alcohol, you guys. I don't have any deep set beliefs against it. I think God's cool with it, but alcohol just makes me sleepy, I'll be honest. I don't drink it much at all because it just makes me want to take a nap. And I can take a nap on my own time. I don't need alcohol to do that for me. Okay. Are you ready? We're going to draw the parent functions one more time. You're going to be so sick of them. I mean, are you all ready? Maybe. Okay. 1, 2, 3, 4. Here's the parabola. Pretend it's perfect. F of x equals x squared. Here comes the cubic function. Woo! That one's so fun to draw. I'm sorry. This is the g of x equals x cubed. Then we have the square root and the absolute value, which I'm really struggling to draw today. Now there's a good looking absolute value function. I got a little crazy right there, didn't it? And we're calling it P for reasons only John understands. When you get to heaven, ask him. John, H, F, G, H, P? Really? Why? Tell us why. Okay, those are our parent functions. This time we only have one variation to show, but these are called reflections. Aw, doesn't it sound like a rippling pond? A second, I want to make my... Okay. So now we only have to draw one more set of these. 2, 3, 4. Reflections are fun to draw because there are two ways to draw them. You can draw them so that it's like a mirror going up and down, or you can draw them side to side. We're doing the up and down kind, and that's called reflections about the x-axis. Now, this is a weird expression, about the x-axis. What that means is that the x-axis is the mirror. That's our flipping point. You can do them this way, but we're not going to look at those in this book or next year's book either, for that matter. We're only going to go top to down. Top to down? Yeah, that kind of makes sense. So here's our quadratic function reflected about the x-axis. It looks like this. How do we fix the equation to make it say that? Are you ready? With a minus sign. Huh. Okay. Now this one, we're going to reflect about the x-axis. That means this part will come down and this part will go up. So it ends up being, whoa, that's kind of trippy, right? And let's see, how do we do that? G of x equals minus x cubed. Okay, we're not going to talk now about why mathematically this makes sense. I just want you to see the picture and to understand how you change the equation. We'll get more into the algebra behind it later, but for now, like I said, this is an art project. Okay, here's a reflected, right? This guy's up, so we're going to flip him down, so he's going to go like that. That's an h of x equals, and here we put the minus on the outside of the square root sign, and then this little dude, the p of x equals, again, the minus sign goes on the outside. Okay, so nothing fancy with these minus signs. They just go on the outside of the dealio. Okay, and then, you know how we've been writing kind of an abstracted rule at the top? So for about x reflections, the f of x equals minus the original function, right? The reflected function, you just smack a minus sign in front of that, and remember that it just goes on the outside of those. It doesn't have to hang close to the x. Okay, and then here's one more example. Sketch the graph of okay, so we look at this, we go, okay, we know by this uppercase that it is not one of the parent functions. The parent functions have the lowercase letters. So that's super helpful. So we know this is one of our newfangled versions. Sorry, I just yawned. See, just talking about alcohol made me want to get sleepy. I don't really like the taste of most alcohol either. Like whiskey. Have you guys ever tasted a sip of whiskey? It's like drinking fire. It's intense. Not anything I can recommend. Okay. What a sidetrack. What a sidetrack. Okay, so we know by this minus sign that this must be a reflection about the x-axis. So we know that it's like putting a mirror in and flipping it down. It's the cubic function, cubic. So normally that goes like this, so it goes like this, right? It goes the opposite. All right, that is our solution, yay. And we can put an F by this to show that that's the name of this function. That's a cool thing about functional notation too, is like I don't have to write this. I can just go, dude, that's F. Okay. Cool. Now, the last part of this does not require any more art projects. We're going to take what we know, and what we're going to do is we're going to learn what happens if you combine shifts and reflections, right? We learned vertical shifts, horizontal shifts, and reflections. So what happens if you mix them together? One more piece of paper. Ready? And we just have one problem. There's no chart to do to this. 110.4. Sketch the graph of f of x equals minus absolute value of x plus 3. Okay, so we know that it's not a parent function. We can see that it's an absolute value function, so we know it's that basic shape. But we see two changes going on. We see that and that. Okay, so we have to be detectives, and that's what makes these problems, I think, kind of fun, is that there's not a lot of mathematical calculation. You just have to be a detective. So we see two weird things that are happening. We have to figure out what they are. This minus sign is a reflection, right? And this, let's see, this is the change that's tacked onto the end. That's what we started with. So that's a vertical function. And so that's vertical shift. We know that if it was a horizontal shift, it would be tucked up next to that x. So this is the first kind that now seems so cute and easy. So we're going to move it 3 units in a positive direction, 3 to the right. Okay? So it's upside down and it's shifted 3 to the right. So now we can draw the picture. 3 units to the right, 1, 2, 3. So that's where our point's going to be. And it doesn't go up, it goes down. So, and we can call that F. Oh, right. I did it wrong, though. I shifted it horizontally and I said it was a vertical shift. So never mind. Don't pay attention to that. Vertical shift is this way. It's 3 to the up. That's not good grammar, but you know what I mean. Okay, ready? Now I'm happy. That's the right answer. This is the horizontal shift instead of a vertical shift. This is right. Yay! And I'm going to put an F right here so everybody knows that's that. Okay, the homework problems are pretty straightforward. I think you'll be fine. But these combinations will test you, and using your notes is absolutely fine in the beginning to try to keep your head on straight. Okay, longest lesson in the history of Algebra 1. Thank you, goodbye.